Today we're going to be focusing on conversion factors and dimensional analysis. Admittedly, this is one of those subjects that is probably one of the most troublesome for students, but it's also one of the most necessary in that you'll be using it for quite a long time. I shared with you let's see, there it is. I shared with you our conversion factor workshop practice problems. We're going to be using this as a framework, but I'm also going to be giving some additional notes on this as well. So what is a conversion factor? What is dimensional analysis? Well, first of all, dimensional analysis is just a really kind of fancy, unnecessarily fancy way of saying converting between units. So dimensional analysis is just a fancy way of saying converting one unit to another unit using conversion factors. And conversion factors, what are those? Well, conversion factors is a fraction. Conversion factor is a fraction where the numerator and the denominator represent equal values or related values, but in different units. So what are some examples of this? Well, there's some obvious examples. There's some obvious examples of this, and there's not so obvious examples of this. So let's start with the obvious examples. So obvious examples of conversion factors. So this would be something like, let's go ahead and insert an equation here. But this would be something like this, okay? Actually, I'm going to insert, I'll put in several of these. Okay. So one obvious example would be like 12 inches, and that's equal to 1 foot. So we know that 12 inches is equal to 1 foot. So if we put 12 inches on top and 1 foot on bottom, that's a conversion factor. And here's the other thing. A conversion factor can always be flipped, because if the numerator is always equal to the denominator, that means you can always flip the conversion factor and use it in the inverse way, 12 inches, 1 foot on top. And which one do you use? It depends on what you're starting with. You're always trying to cancel out the unit that you're starting with. And so whatever unit was previously on top, that's the unit that goes in the bottom. Now, every measured value is composed of two parts. Any measured value is composed of two parts. The number, that would be this part, and the unit, the letters that describe what this is a measurement of, okay? So when we're doing dimensional analysis and using conversion factors, we really want to focus not on the number, but on the units. If we focus on the units, we are far more likely to not make any mistakes. Okay, so what are some other obvious examples of conversion factors? Well, let's say we have 1 liter is equal to 1,000 milliliters. Another one that you'll probably see is 1 kilogram is equal to 1,000 grams. Okay, so let's look at some not obvious examples, because these are the ones that are going to kind of mess with your brain a little bit. So Not obvious examples of conversion factor, pretty much anything you can think of. Um, for example, if you were to, I mean, it's almost Valentine's Day. Let's say you were to buy a diamond necklace. Well, if you're a guy, you'd buy a diamond necklace for your girlfriend, okay? Um, I guess if you're a girl, you could buy a diamond necklace for your boyfriend, but I don't know how he'd feel about that. But let's say you paid, let's say you paid 1,025 bucks for this diamond necklace, okay? In that case, you could say one diamond necklace is equal to 1,025 bucks. That is a valid conversion factor if, in fact, a diamond necklace cost 1,025 bucks. Now, it's a limited conversion factor. It only works for a particular type of diamond necklace, obviously, but it is a valid conversion factor. What are some other not obvious conversion factors? Um, how about density? That's one that you're going to be using. You'll use density a lot. Let's say you have a density of 2.54 grams per milliliter. So in other words, it might say 2.54 grams per milliliter. That might be a density you're given. Well, when you're given density, you can use it as a conversion factor. So I could write this as 2.54 grams per 1 milliliter. So 2.54 grams per milliliter. Okay. So that's a valid conversion factor as well. If you are driving 75 miles an hour on the highway, 75 miles is equal to 1 hour. 75 miles is equal to 1 hour. That is also a valid conversion factor. So essentially any fractional unit and anything you can set equal to something else can be used as a conversion factor. So let's take a look. So based on that, let's take a look at some of these practice problems, and I'll go through some strategies um, for solving these types of problems. One last thing I'd like to leave you with is this. Since conversion factors are equalities, that means when you convert a unit from one to another, you're not changing the amount. You're simply changing how that amount is expressed. This leaves us with a very important um, understanding that will help you with some of these conversion factor problems, and that is this. When converting, what you start with will always be in some way equal to what you are looking for. Always start. That seems to be one of the most difficult things about converting is that when students are using conversion factors and they're trying to solve a particular problem, they don't know what to start with. You start with what you're looking for. You start with something that is in some way equal to what you're looking for. I'm actually going to go ahead and highlight this because this is a really important point. Um, so let's do a little practice example. It says you have to plan for a pizza party for your office. If 45 people are coming to the party and they eat an average of 3 slices of pizza per person, how much money will it cost to buy pizza for the party? Each pizza has 8 slices and costs $8.50. So I am looking for how much money it costs to buy pizza for the party. That's what I'm looking for. Okay. What value is equal to that? What value is equal in some way to the money it costs to buy pizza for the party? Or you could also look at it, what value determines how much it will cost to buy pizza for the party? What do you think? What number should I start with? Oh, and by the way, I know I gave a little bit of a monologue at the beginning, but I would love for this to be an active session. So please feel free, if you wish, to turn on your mics and speak freely, ask questions, and things like that. Yes,
Do you start with 4 or 5 people per 3
you got
pieces?
it. You got it. You got 45 people. That's exactly right. Because the 45 people, the number of people coming determines the cost for the party, right? That's perfect. Absolutely. Um, so yes, we'll start with 45 people. And I'm going to go ahead and insert an equation. So 45 people. So then I can multiply this. Go ahead and multiply. And we'll start with our first conversion factor. So I know that what's going to have to go on the bottom is people or person. Okay? People or person. All right. So what relates to a person? How can I relate a person to something else? Is there any sort of relationship that's in the problem?
The slices of pizza,
Yep,
the amount they eat,
exactly.
3 pieces.
You got it. So it's 3 pieces of pizza. So 3 pieces of pizza for every one person. All right, and so now we'll go ahead and continue from there. And we can go ahead and set up another fraction. What unit's going to go on the bottom of this one?
The number of slices in a whole pizza,
Yes, and or at least we would say slices or pieces of pizza, right? That's the unit. We don't have to worry about the number, but yes, absolutely, pieces of pizza, and we only can really relate, as you kind of alluded to, the pieces of pizza is related to the pizza itself, right? Every one pizza has 8 slices, correct?
yeah.
And now we have a pizza. Now, what can we convert pizza to?
Uh,
Amount dollars per slice,
Well, there's no dollars per slice,
or dollars per
but
just
pizza.
for pizza.
yeah, exactly, dollars per pizza. So I can say, okay, well, pizza has to go on the bottom,
It's on the bottom and price on
and
the
I
top.
can relate the cost to it. So 8.50 is the cost for one pizza. And that's just a practical, real life example of how you can use this to solve for something, to figure out something in advance of, say, like a major pizza party. So what we'll do is we just multiply everything on top and divide by everything on bottom. So we'll say 45 times 3 times 850 divided by 8. And that gives me
And 43.
$143.44. Okay, 44 cents. Now, of course, I guess if we were being a little bit more realistic, we're not going to actually end up buying pizza by the slice. So we could stop short of this last one and just say 45 times 3 divided by 8 to get a rough count of the pizzas. Will be 17 pizzas because we're not going to buy 16 and,
Fraction of a pizza.
exactly. So it would be like 17. And so 17 times 850 would be 144.50, which is pretty close. But yeah, so I mean, We always have to apply logic. We always have to apply a little bit of common sense when we're doing these calculations. Um, and it's actually a well, you might not think of it like this, but applying logic to our mathematical situations to make sure that it reflects reality. There's a fancy word for that you might have heard. It's called philosophy. Philosophy is logical reasoning in the search for truth. And interestingly enough, it is actually an important part of science because you need to philosophize or logically analyze using reason your research and other things in chemistry and indeed all sciences in order to come to conclusions that are well founded and also reflect reality. So, and this is obviously very simple. It's not like any sort of crazy advanced philosophy, but it's just a little something I like to toss out there. All right. Now, sometimes you'll get more information than you really need in a problem. And you might be tempted to try to work in all the numbers that are in a given problem, but it's not always necessary. For example, it says Drew jogged 15,840 feet in 45 minutes. How many miles did he jog? So what number would I start with here?
The
Uh,
feet he went.
Yeah, the feet he went. Um, and so that would be, uh, and so my apologies. I didn't consider when I invited you all to speak that it might create issues if people were talking over each other. So, but that's very good. I'm glad to have you here. So here's what I would say: uh, if if you answer, um, gosh, I hate to do this because I hate to restrict it, but if you hit the little raise hand button here, if you think you have an idea, if you want to share, just go ahead and raise your hand like that. It's in the, and you can just and proceed to answer or ask a question, and that would be great. Awesome. Yeah, the raise hand button is in the bottom of your screen. It's next to the turning on your audio and your camera. All right, cool. So looking at this, as you just said, here we go. We're going to start with 15,840 feet. And we're going to, it says how many miles did he jog? So what unit goes on the bottom here? Ralph?
The number of miles, or how
Yep.
many miles?
Well, actually, miles would not go on bottom
Okay.
because
Oh,
remember
the
we have to,
yeah, 1 foot. You would need to put
yeah,
1 foot, and then
well,
the
feet would go on bottom. And here's why I always emphasize focus on the units first. Don't put any numbers until you have the units in place. Because if you don't know what you're converting between, then you don't know what numbers are going to go there. So, but you're right. Foot is going to go on the bottom. What's going to go on top? What unit? Carissa?
How many miles
You
are
got it.
going to be
Absolutely.
in? Yeah.
So miles, yeah, that'll work. Miles goes on top. Okay, so here's the deal. Got feet on the bottom, miles on top. Now, how many miles are equal to a foot, or how many feet are equal to a mile? Now, you may not know that offhand. Go ahead, Krista or Ralph. Oh, 5,280. Thank you, Linda. All right, awesome. 5,280. That is absolutely correct. So 5,280 feet is equal to 1 mile. There we go. So it looks like we already have miles. When the unit on top matches the unit you're looking for, that's when you stop. Notice we did not use 45 minutes. It was not necessary for us to do so. And so, in this case, we can cancel out our feet, by feet, and we're going to end up with 15,840 divided by 5280, and that's going to give you 3.000. You might ask me why it's 3.000 instead of just 3.0 miles. Anybody want to answer that question? Go ahead. Ralph?
Because of the number of significant figures, and 5280 has the smallest amount.
Well, actually, it's not 5280
Oh.
because you're correct.
Oh,
It is
you went
significant
to.
figures, but
I'm sorry, you went to 3 zeros after. So okay.
it's the interesting thing is here is that how many significant figures are in the 1 mile for 5,280 feet?
4.
Actually, it's unlimited
Oh.
because 1 mile is equal to 5,280 feet is a definition. So it has unlimited significant figures. However, the 15,840 feet has only 4 significant figures. Generally speaking, now there are some exceptions to this, but at least early on, most of the conversion factors that you're going to run across are going to be conversion factors that have unlimited sig figs because they're definitional values. Like 100 centimeters is equal to 1 meter, or 1 foot is equal to 12 inches, or something like that. Yeah, so nice. Yeah, those things have unlimited significant figures because they're definitions. They actually aren't measured. Those things are by definition. Um, so usually the significant figures that you start with is going to be equal to the significant figures that you end with. So I started in this case with 4 significant figures because that last 0 is not significant because there's no decimal on that 15,840. Started with 4, and so I'm going to end with 4, and 3,000 miles is going to be my answer. Cool. Very good. All right, so now let's take a look at the next one. Tori measured a beetle in biology that was 2,600 micrometers long. What is the length of the beetle in millimeters? So this is what is referred to as a metric conversion. There's only one number here, so it's pretty obvious we have to start with the 2,600 micrometers. Now, micro has this goofy U-looking symbol. It's actually a Greek letter mu, but it looks like kind of like a cursive U, micrometer. And we're going to go ahead and multiply that times the conversion factor. Now, so what unit's going to go on the bottom here? What unit's going to go on the bottom? Go ahead, Ralph.
The micrometer.
Yeah, micrometers is going to go on the bottom. What unit's going to go on top?
Millimeter?
What do you think? I tricked you. You would think it would be millimeters. You would think it would be millimeters because the unit that you're looking for is usually what you want to go on top. But the problem is we have no reference from micrometers to millimeters. Because the metric prefix is only references to the base unit, which is meters. So unfortunately, when you're doing metric prefixes, you're doing from one prefix, micro, to another prefix, milli. We have to first go through the base unit. We have to first go through meters. Okay. So There's actually a really cool thing. I'm going to share something with y'all. Actually, a really cool conversion chart that I'd like to share with you because I'm going to paste it in the chat because this conversion chart is super helpful. Oh, well darn. I know where it is. To hunt it down a little bit. Let's see. I need to put it on the website, but I have it on my Google Drive, table of conversions. Here we go. Oh, share. Get link. Here we go. So I'll pop this link in the chat. I'll also post this on the website under the workshop so that y'all have access to it. But here it is. This is a useful little table of conversions here. You can click on that, and it'll pull up all the prefixes, but it also has some good English unit conversions and English to metric conversions. So you can see micro, each of these prefixes has a numeric meaning. And when you're doing these metric prefixes, I found that the easiest way to avoid confusion is to put a 1 in front of the prefix unit. So looking back at what I was working with you on, there's two units here. One has a prefix, the other doesn't. So micro, here's my prefix, and then the other is my base unit. I also have a base unit. Meter is the base unit. Okay. So I put a 1 in front of the unit with the prefix micro, and then I put the meaning of the prefix in front of the base unit. Micro means 10 to the negative 6, as you can see from that chart. So micro means 10 to the negative 6. So 1 micrometer is 10 to the negative 6 meters. Does that make sense? Any questions on that? Does that make sense so far?
Yes.
Cool. All right. So then once I have meters, then I can proceed to do the next conversion factor. And feel free to interrupt me or ask questions at any point in time. So this is not like a lecture. We don't have to go through it at any particular pace. Feel free to interrupt, make comments, questions, etc. I absolutely do not mind. I would love this to be as active a session as possible. Okay, so meters goes on the meters is up here. Micrometer has already canceled out. So what unit goes on the bottom of the next conversion factor? Yes, Phil?
I'll take a shot and say meters.
Yep, absolutely. And then what unit goes on top?
Milliliters?
Milliliters or millimeters?
Millimeters.
There you go. Millimeters, absolutely. Very good. All right, so effectively, once again, there's two pieces to this. This is the base unit, this is the base unit, and then there's your prefix unit, and the prefix unit is this one. Okay? So I'm going to put a 1 in front of the prefix unit, just like before, and then I'll put the meaning of the prefix in front of the base unit. So what goes in front of meters? What goes in front of meters? Go ahead.
One. No, I thought it was going to be one.
Not 1. 1 millimeter is not equal to 1 meter. Remember, the top has to always equal the bottom.
0.001.
Exactly. Milli means 1/1000th. 0.001. Now and you could also put 10 to the negative third. Now you might ask me, well, my professor said uh, it's 1,000 millimeters to a meter or 1,000 milliliters to a liter, and that's true. It is. Why did I bother having you put 0.001 meters is equal to 1 millimeter? The reason is this: milli means 1/1000th, but kilo means 1,000. If you're using 1,000 for the millimeter conversions and you're using 1,000 for the kilometer conversions, can you see where you might start, where it's possible you might start getting mixed up and flipping and using the wrong things? You're using the same number, but in a different way.
Yeah.
So it's usually a good idea. Like I said, I recommend you certainly if you're careful, if you check yourself, you can certainly use any valid conversion factor. If you wanted to, you could put 1,000 millimeters on top and 1 meter on bottom, and that would be correct. But if you have to memorize these metric conversions, it might be easier. I might recommend just, and you don't have to memorize a lot of them, but milli, centi, kilo, deci, those are ones that are going to come up a lot. And so if you know what their meaning is, that milli means 0.001, and you know that kilo means 1,000, and you know to put 1 in front of your prefix unit, you're going to be good, and you're not going to make any of these mistakes. So ultimately, it comes down to that basic principle we discussed at the beginning, that a conversion factor is a fraction where the numerator and the denominator represent equal values. You can just ask yourself, is the numerator, is what's on top equal to what's on bottom? If it's not, then you can probably recognize, whoa, that doesn't look right. I better fix those numbers. Okay, cool. So now all we have to do is multiply the top and divide by the bottom. 2,600 times 10 to the negative 6, and then divide by 0.001. And what do you get? What do we get for our final answer? Yep, absolutely, 2.6. Very well done. 2.6 millimeters. Tiny beetle. All right, cool. So, skip to the medicine vial. All right, so this is a question, this is kind of a question that's pretty common, and it's something that you'll come across, especially also if you're going into any sort of nursing program or whatever. Pharmacology is going to be something that you're going to probably end up having to brush up on, especially with those little tests that they make you do, like the HESI and such. So let's take a look at number 5. So the vial of medicine contains 3 centiliters of liquid. 1 dose of medicine is 5 milliliters. How many doses of medicine are in the vial? So here's what you're going to have to do. First of all, what am I going to start with? I'm looking for the doses of medicine in the vial. What number am I going to have to start with here? I assume you're going to say 3, right?
Yes, thank you.
Yeah, no problem. So got 3 centiliters, so it's CL. Then I'm going to go ahead and put in a conversion factor. Now what unit's going to have to go on the bottom of this conversion factor? Yes, go ahead. Frank?
Milliliters.
Not quite milliliters. Well, Myra, good job that you caught it. It's centiliters.
Okay,
Centiliters.
centiliters.
Yep. Now, what unit's going to go on top? This is a tricky one. Wait. There we go. Good job, Carla. It's absolutely, it's liters. The liters has to go on top. So centiliters is going to go on bottom, but liters has to go on top because I can't convert one prefix unit to another prefix unit. The prefixes only refer to base units. So this is how I'm going to have to relate them. And you know what? I'm actually going to not worry about the numbers yet. I'm just going to keep on doing with units. So What unit's going to go on the bottom of the next conversion factor? Yep, very good. And liters goes on bottom. And then what's going to go on the top? Milliliters. Very good. How are you on fire? Knocking these down one by one. All right, so let's go. And then after that, now here's the thing. We're not looking for milliliters though, right? We're looking for doses of medicine. So that means we have one more conversion to go. What unit's going to go on the bottom of this third conversion factor? Milliliters, that's right. And what unit's going to go on top? One dose. Very good. So notice the pattern here. Whatever was previously on top always comes on the bottom. Previously on top comes on bottom. Previously on top comes on bottom. It's the same pattern. You're always canceling out the previous unit until you get to the unit you're looking for, doses. Now, of course, with the actual prefixes, 1 centiliter is equal to 0.01 liters. Now, that's just because centi means 0.01, metric prefix. You could also put 100 centiliters is equal to 1 liter if you prefer. Once again, the metric prefixes. What numbers am I going to put in front of milliliters and liters? What do you think? How many milliliters are in a liter, or how many liters are in a milliliter? Okay, 1,000 milliliters. You want to do the 1,000? That's totally fine. And that's in how many liters, Frank? You got it. Hold on, sir. Now, how many milliliters in a dose? Yep, there we go. So 5 milliliters. And somebody had already kind of said that, but yeah, 5 milliliters in one dose. So there we go. Now we can actually calculate how many doses are in this thing. That's 3 centiliters, 3 times 0.01 times 1,000 divided by 5. Notice I don't actually bother multiplying or dividing by the ones. But yeah, the easiest way to do these on your calculator, trust me, the easiest way to do these on your calculator is just to multiply all the numbers on top and then divide individually by each of the numbers on bottom. So 3 times 0.01 times 1,000 times 1 divided by 1 divided by 1 divided by 5. Now, of course, if it is a 1, you can skip that. Because if you multiply something times 1, it's going to be the same thing. Divide something by 1, it's going to be the same number. All right, and if you go ahead and calculate that, you should end up with, very good, 6 doses. Well done, well done. You guys are champions at this already. Doses. There we go. Bam. All right, let's take a look. Now, let's say you have something that's a little bit weird, like this combination unit. Speed of light in a vacuum is 2.998 times 10 to the 8th meters per second. Calculated speed in kilometers per hour. So every now and then, in rare cases, you'll be given a combination unit. You'll be given a fractional unit to convert. And you can still do this. It's just that when you do a fractional unit, you start with a fraction. So this ends up being 2.998 times 10 to the 8th meters. Notice it says per second. When it says per second, that's always per 1 second. Just like if you were driving in a car at 75 miles per hour, that's 75 miles per 1 hour. Or if it's $2 per dozen, That's $2 for 1 dozen. So anytime you see per something, it's always per one of that something. So miles per hour, kilometers per hour, etc. All right, cool. So we got this to start off with. And now we'll set up our conversion factors to convert this. Now we can't convert both of the units at the same time. We're going to have to convert one at a time. So in this case, you could actually choose to convert either of these units. Which unit do you want to start with? Should we convert meters or do you want to convert seconds? What do you think? Time. Okay. So if we want to convert seconds, now once again, we have to cancel it out. But interestingly enough, seconds is on the bottom to start. So if we want to cancel it out, where is seconds going to go in our conversion factor? Yeah, on top. Exactly. So I'll put seconds on top. And what can I convert seconds to? What can I convert seconds to? Minutes. Yeah, you could convert the seconds to hours, but not everybody knows offhand how many seconds are in an hour. But you definitely can convert seconds to minutes because we all know that there is 60 seconds in 1 minute. Now, we can also then, we haven't gotten the unit of time that we're looking for. We're looking for hours. So we actually have to do another conversion factor. Note that the seconds has canceled out, which means, what do I have to cancel out now? Minutes. Yep. 60 minutes go over 1 hour exactly. The 60 minutes goes on top, 1 hour goes on bottom, and I totally just messed up my little things. Here we go. There we go. All right. So 60 minutes is equal to 1 hour. All right, great. Now minutes is canceled out, and I can actually go ahead and convert meters to kilometers. So I'm going to add another conversion factor. Actually, let's do this. There we go. Let's go to home. Get into my design chart. There we go. All right. Now we can go ahead and put a fraction in there. Now I need the meters to cancel out. So what unit's going to go on the bottom? Meters, yep. And what unit's going to go on top? Kilometers, very good. So once again, I'll put a 1 in front of my prefix unit and the meaning of the prefix in front of the base unit. What does kilo mean? What's the numerical meaning of kilo? 1,000, very good. So kilometer is 1,000 meters. And so now I can multiply everything on top and divide everything on bottom, and then I will be good to go. So let's see. Let me draw. I like drawing. There we go. Minutes goes bye-bye. Meters goes bye-bye. And I just multiply everything on top, divide everything on bottom, and then I calculate the final answer. And that's going to give me so 2.998 times 10 to the 8th times 60 times 60 divided by 1,000. Wow, that's a big number. 1.079 times 10 to the 9th, I think. Yeah. 1.079 times 10 to the 9th kilometers per hour. Cool? Awesome. Now, yes, go ahead, Rolf.
I don't know. I must have, looking at it, I got I wrote everything down right, but I got on my calculator it came out to 1.8916101119. I don't know where I came out wrong.
Hmm.
I did it twice, 2.998 times 10 to the 8th, and then it's times 60 divided by 1,000.
Uh-huh.
Yeah, I still come out with 1.89. Maybe my calculator's messed up.
Well, it could be how you're putting in the times 10 to the power. What I would recommend, do you have a little EE button on your calculator?
Uh, yes.
Okay, type in 2.998 and then hit the EE button and then hit 8. And then times 60 divided by 1,000.
Okay, got that.
So that fixed it?
Yes.
Yeah, it was probably the way you were typing it. Um, uh, I don't know why. I'd have to actually probably see your calculator in person to see what it was, but I'll go ahead and, yeah, that's what I would do.
Okay, thank you.
Um, I apologize, my wife came in and all right, so let's go ahead and hit the next building. Um, the EE means times 10 to the power of. EE means times 10 to the power. So whenever you hit EE, it's the same as doing times 10 to the power. So when I write 2.998 times 10 to the 8th, it is the exact same thing on my calculator if I write 2.998 E8. And there's a button on your calculator that does that. It sometimes writes it like EE, or sometimes it will just have E, but sometimes it'll have EE. But that's what it means. It means 2.998 times 10 to the power of whatever comes after it, in this case 8. Cool. Does that make sense? Awesome. All right. So I do want to go over converting cubic units because this is a little bit of a tricky one. So let's skip ahead to number 8. Um, says the vehicle assembly building at Kennedy Space Center in Florida has a volume of 3,666,500 meters cubed. Convert this volume to liters and express the result in standard exponential notation, in other words, scientific notation. All right, so for this, there's a couple of things that you kind of need to know. And this is actually a common conversion factor. So this is definitely one you want to have committed to memory, but effectively, a 1 milliliter is equal to 1 centimeter cubed. Oh, whoops, what was I doing? Here we go, centimeter cubed. So 1 milliliter is equal to centimeter cubed. Um, okay, so the reason that we have liters and milliliters is because we didn't want to deal with cubic units for conversion. Dealing with cubic units for conversions is kind of, it gets kind of crazy. You definitely don't want to deal with that. And I'll show, and you'll kind of see why in just a second. So that's why in chemistry and um, in other science fields, we typically prefer to use non-cubic units when expressing volumes. Now, we'll start with the 3,666,500 liters. Oh, look, I think I have a question. Then American thing with regards to liters, or what?
No, like like we don't like to use the metric system.
Oh no, see, actually, liters is the metric system.
Okay, cool.
Yeah, so liters is part of the metric system. It's just when we're dealing with volume, it just makes a lot more sense rather than doing centimeters cubed and meters cubed, because there's a huge difference between centimeters cubed and meters cubed. We decided just to use we call we call a deciliter cubed a liter, or a decimeter cubed a liter,
Okay,
or
cool.
a centimeter. Yeah, it makes for easier conversions if we can use a base 10 unit rather than trying to do a cubic unit. So
Okay, cool.
let's go ahead and start with our 3,000 or 3,666,500 meters cubed. Okay, let's start with that. Only one really unit that we can start with, so and then we'll go ahead and multiply. Here we go. And then what unit goes on the bottom? You might think it would be meters cubed. Now, liters isn't a bad guess, but in this case, it's not going to be either one. See, what we're going to need to do here, and you could, and you could do meters cubed, but it would be much more problematic. We're going to end up doing um, we're going to end up doing meters, and we're going to convert to centimeters because I need to somehow get this to liters, and my link from milliliters or my link from liters to meters is the centimeter cubed to milliliters. So I have to get this somehow into centimeters cubed. So I'll put meters on the bottom and centimeters on top. And so centimeters, but here's the thing. I can't just do this once. So there's two things that I can do here. I can either cube this, I can cube the entire conversion factor, which is certainly fine to do, or I can just repeat the conversion factor 3 times. Because I think it's a little bit easier to see calculation-wise, I'm just going to repeat the conversion factor 3 times. Now, here's the thing. Now I'm going to have to go ahead and put the numbers in. Now you could, like I said before, you can either do 100 centimeters is equal to a meter, or you can do 1 centimeter is equal to 0.01 meters. I'm going to I'm going to be consistent and do the 1 in front of the prefix unit and then the meaning of the prefix in front of the base unit. Centi means 1/100th, so it's centi is going to be 0.01 meters. And then I'll just repeat that. 1 centimeter, 0.01 meters. 1 centimeter, 0.01 meters. Now that I have centimeters cubed, because meters is just like in algebra, meters times meters times meters gives you meters cubed. You multiply and divide units just like you would variables. So meters cubed cancels out with meters cubed. So I can go ahead and cancel that out. And now I can convert the centimeters cubed. Now I can convert centimeters cubed into milliliters. So I will go ahead and I'll put 1 centimeter cubed on the bottom here. That's equal to 1 milliliter. And then from there, I can convert milliliters to liters. So 1 milliliter is equal to 0.001 liters. All right. Slide cancellation out. So yeah, so whenever you're converting like square units or cubic units, you have to kind of repeat the conversion factor as many times as it takes to cancel out all the meters, shall we say, or whatever the cubic unit happens to be. In this case, it was meters. Does that make sense? Cool. So then we can just multiply everything on top, then divide by the bottom, and we're good to go. What does that give us if we calculate that? Go ahead.
Mr. Dr. No.
I'm sorry?
Oh, hi. Okay, so I only got the first half of it right now. The top part. When you get when you multiply everything, the next step is divided by each 0.01
Yes.
3 times. Okay, so 0.01, 0.0.
Good shot, Ralph. Well done. The only thing that I could critique is your lack of significant figures. Right, except for sig figs. So, remember, not all these are definitional units. Metric prefixes are definitional units, so which means that the number of sig figs I start with, the 5, is going to be the number of sig figs I end with. So, y'all are getting the right number, it looks like, except for the fact that you're not using the right number of significant figures. It should be 3.665 times 10 to the 9th. Does that make sense? Cool. All right. So let's see. I wanna try to do one a little bit more tricky. Let's do this one. Technically speaking, we're uh, out of time, but if y'all don't mind staying with me for one more practice problem, let's go ahead and take a shot at number 11. And it says the doctor orders an antibiotic to be given to a patient weighing 185 pounds. The order prescribes 25 milligrams per kilogram of body weight to be taken daily. If the antibiotic is sold as 300 milligram tablets, how many tablets will the patient need to take daily? So, that's a lot. What are we going to need to start with here? What number do we need to start with? Yeah, Ralph, go ahead.
The 185 pounds, you need to convert that to kilograms.
Yeah, the weight of the patient determines the amount of the dose, exactly. And Carla was basically saying the same thing. So, well done, Carla. All right, so we need to go ahead and start with 185 pounds. I'm going to go ahead and leave it in the draw mode. I like drawing. 185 pounds. What on earth? Okay, let's do that to me. Okay, 185 pounds. So I get my conversion factors. What unit goes on bottom? Yep, pounds. And what unit goes on top?
Kilograms.
Kilograms, very good. And why do we choose kilograms, by the way?
Because the doctor said that it needs to be 25 milligrams per the kilogram of body weight.
Exactly. We need some reference to the medicine, and the reference is not to pounds of weight, it's to kilograms of weight. So for this metric prefix, you'll have to look at that conversion table I shared with you, and you should note that 1 kilogram, based on that conversion table, is roughly about
2.2.
yeah, 2.205 pounds. All right. So pounds is canceled out by pounds. Now we can convert kilograms. And you already kind of hinted at, or you already kind of, yeah, directed us to the next conversion factor, which is the order of the doctor. So 25 milligrams per kilogram of body weight. Kilogram has to go on the bottom. Milligram has to go on top. All right, so now the tricky part here is you might be like, well, milligrams to kilogram, that's a metric conversion. Well, not exactly. If you just write it like that, you might think it's a metric conversion. This is actually not a metric conversion because we have to keep in mind that we're actually comparing weights of different things. This is milligrams of medicine to kilograms of weight, body weight. So there's no metric conversion that allows us to convert between those. We need the order from the doctor to be able to do that. And as you mentioned, it was 25.0 milligrams of medicine per kilogram. It says per kilogram. Well, that means for how many kilograms? 1. Yep. So now we can proceed to convert milligrams of medicine to tablets. Milligrams of medicine is going to have to go on bottom. And I actually should have asked you, I apologize. Milligrams of medicine has to go to tablets. Now, how many tablets are equal to how many milligrams? What numbers do I need to put here?
Oh, 300 at the bottom and 1 tablet on top.
You got it. 300 on bottom and 1 tablet on top. Very good. And that's it. That's all you have to do. So you multiply everything on top and divide by the bottom. It is 185 times 25.0 divided by 2.205 divided by 300. 6. And the answer you get is 6.99 tablets. However, using reason, well, it actually does say round to the nearest whole tablet, but if it didn't say that, one could reasonably assume you're not going to take 6.99 tablets, right? It's going to be 7. Yeah. Maybe if it was 6.5 tablets, yeah, you could cut a tablet in half, but I can't cut a tablet into 100 pieces. Not without some equipment that you didn't want to, that you're not going to want to pay for. All right. So I like these. Medication conversion factor type problems. We all good with that? Everybody understand that? Is that good? Cool. All right. So I'll leave it up to you. We can stop there, or if you want, you can go and take a shot at this next one, and I won't actually help you with it, but I'll check it. We can check it together afterwards. Do you want to do that? You want to take a shot at number 12, and then we can check it after? All right, let's do it. I'll give you a few minutes to work this out, and then we'll go ahead and check it together. Once you have an answer that you think is correct, go ahead and hit the raise hand button, this little guy. Once you have an answer you think is correct, hit the little raise hand button to let me know that you're done. By the way, if you reach the point where you want to give up, and you can just raise your hand for that too. but yeah, either if you get the answer or if you want to give up, you can just go ahead and raise the hand, and we'll go over it. No problem. Take your time. All right, let's go ahead and take a shot at this. All right, let's see. So, what did y'all start with? Let's start with that. What number did y'all start with here? Oh, interesting. Now, I will say this. One could use possibly 115, depending on how you did the rest of them, but it does make more sense to use the 34 pounds. You could start with 115 and get the right answer, but it does make more sense to do the 34 pounds. I'm actually going to show you both ways of solving this. Okay, so let's start with the 34 pounds, because that actually is probably the more straightforward way to approach it. All right, so if we do start with 34 pounds, what do we do? If we start with 34 pounds, what do we do? What goes on the bottom? Yes, go ahead.
You need to convert that to kilograms.
Exactly.
And
And
you would
let me
have
guess.
the 1 kilogram is equal to 2.205 pounds.
Ah, yes, absolutely. So 2.205 pounds is equal to 1 kilogram. So that's very good. And then after that, what's the next conversion factor in the series? We would know that kilograms has to go on bottom, right? So what goes on top? Yes.
The milligrams of the dosing.
Yeah, milligrams of medicine. In this case, the 115 milligrams, right? For every 1 kilogram of body weight. Oh, let's do DW. All right. And next, we need the teaspoons of the medication. So we're definitely not done yet. We have milligrams of medicine. What's the next step? What can we convert milligrams to?
Grams?
Very good. And that one's not obvious. Because the only thing that relates the volume, you're getting teaspoons, right? And teaspoons looks like it's related to milliliters. Well, the only thing that relates to milliliters is grams. And we have milligrams, not grams, so we have to convert the milligrams to grams. So sometimes you can actually even kind of do a plan of attack and work backwards on these. But yeah, this is definitely a more challenging problem. We're going to go milligrams to grams. Yes.
I actually was a pharmacy technician for 18 years, so I do it a little backwards way than this, but I came out with I think is the right answer.
Oh, okay. Yeah.
I,
Yeah.
I kind of I go a different way, like converting the weight and then getting the concentration of the medicine, and then going calculating all that. So
Oh,
it's just a
cool.
little different than doing it how we have this set up, but it's just how I was taught in the pharmacy gets a little quicker than doing all these steps.
Oh, yeah. Well, that's awesome. I mean, the important thing though is if you have the understanding of the logical arrangement of these units, though. I mean, yeah. I would imagine that the way that you did it still makes use of the same principles. Am I right?
Right. That's correct.
Okay.
just
So and
set
then
it instead of writing it out in this equation. I just block out my step and then get that number and go to the other and then do the math to get the answer.
gotcha. So 1 milligram is equal to 0.001 grams. Remember, milli means 1/1000, not 1,000. Um, that's an easy mistake to make. That's why I always recommend using the prefix, the meaning of the prefix, 1 in front of the prefix unit, and then the meaning of the prefix in front of the base unit. All right, let's go with the next one. We can convert grams to what? What do we convert grams to? Yep, milliliters. Very good. So it'll be 0.375 grams is equal to 1 milliliter. And then from milliliters, we can convert to teaspoons. Milliliters, CST, 5 milliliters, teaspoon. And this actually technically is 5.0 milliliters. Where this would become important, see, one could argue that this dosage, this 115 milligrams per kilogram. Oh, you can't even see that. Interesting. Okay, so one could argue that 115 milligrams per kilogram is actually a exact number because it's an order from the doctor. It's not something that was measured. However, even if you do accept that, the concentration here, concentration of 0.375 grams per milliliter, that concentration is definitely a measured value. So this is an example where you have measured values that you do have to take their significant figures into account when you're calculating. Furthermore, the 1 teaspoon is approximately equal to 5.0 milliliters. So that now you'll find this a lot, that when you have numbers like this is what's referred to as a reference value, the 1 teaspoon. So that has unlimited significant figures, but the comparison value does not have unlimited sig figs. That's only 2 sig figs. So that's just a good thing to keep in mind. That whatever you usually put the 1 in front of is usually your reference value, and so that has unlimited significant figures. So even though like the 0.375 has 3 sig figs, the 1 milliliter is unlimited. And even though like 2.205 is 4 sig figs, the 1 kilogram, that's unlimited. So the ones don't affect your significant figures. Okay, cool. So what do we get for our actual dose when you calculate this? Yeah, you get about 1 teaspoon. It ends up coming out as like 0.9457, but if you have 0.9457, you can't really measure that many teaspoons out. But, I mean, with the appropriate number of significant figures, you'd say it's 0.95, okay? 3.95 teaspoons. But in truth, 0.95 teaspoons, in all practicality, you're probably just going to measure a full teaspoon. Very good. Oh, so let me show you the alternative way that I was going to hit up with you. If you did do the 115 milligrams per kilogram, okay, here's 115 milligrams per kilogram of body weight. The trick here is that you basically have to convert the body weight to the child, which is weird to get the final answer. So effectively, if you did it this way, let me actually go ahead and pop this in. Do a bunch of them all together. I saw a comment. Let's see. Yeah. Um, if you do it this way, you can definitely do it this way, but what you do is you put, and you can really convert the kilograms to the child first if you want, or you can convert milligrams to the teaspoons, but let's just say I do the milligrams first. That's the milligrams on bottom, and then once again, that's milligrams of medicine, so I'd have to convert to grams of medicine. 0.01 um, equal to 1, and then that grams of medicine would then have to get converted into um, milliliters. So we would go ahead and do 0.375 grams equal to 1 milliliter. Yes.
I wanted to ask a question, and the question is that when we are given a multi-choice question and we just needed to quickly give an answer, is it possible for you to also teach us how the shortest cut we can just arrive at the answer when we do not really need to show our calculations out?
Whew. Well, let me put it this way. You will very rarely, if ever, be given a problem that requires as many steps as the one that we've just done uh, does. However, um, when it comes to these types of conversion factor problems, I would not recommend skipping the showing your work part.
Oh, okay.
I know it seems like you'd save some time, but
Yeah.
it only seems like that now. It just only seems like it takes a long time now because you're having to think about each step. But
Yes.
as you get more familiar with it, it will become more automatic,
Yeah.
and you'll be able to do it a lot more quickly.
Okay. Makes
Um,
sense.
so yeah, so what I would encourage you to do is I would encourage you to practice this a lot and show your work while you're practicing it. Then on the test, if you feel comfortable not showing it or skipping some steps, you can. But I mean, to make sure you're doing it right, I have to confess, I really probably would kind of encourage you to write it out, to do it.
Thank you.
No problem. All right, so and then we have the teaspoons, and then all I have to do then is to do the one last step of converting the kilograms, 1 kilogram on top to 2.205 pounds on bottom. And yeah, I'm trying to think if I missed anything. Nope, I think that's it. Oh, yeah, no, actually, one more step. I have to convert the kilograms to a child, which is the oddest conversion factor. So, 34 kilograms equals one patient, one child patient. Oh, no, 34. Oh, whoops, my bad. It's 34 pounds, and that goes on top. Sorry, 34 pounds is equal to one child patient. And this is also why you want to show your work, because what I just did just there, I switched the numbers from top to bottom because I wasn't paying attention to the units that came before. Um, I took my eyes off the ball for a second. So writing down the units can really be a good check for yourself. So milligrams cancels out with milligrams. Grams of medicine cancels out grams of medicine. Milliliters cancels out with milliliters. And I'm left with teaspoons. This is what I want. Teaspoons. Um, then pounds or kilograms of a weight cancels out with kilograms of weight. Pounds has to cancel out with pounds, and so I needed to put the pounds on top. And then pounds cancels out, and I get patient. So this ends up being essentially the 0.95 teaspoons or 1 teaspoon per child. I don't. That just feels a little weird to me, which is why I like this. But it can be done starting with the 115. You just kind of got to take into account that the child's weight is 34 pounds. Does that make sense? Cool. Awesome. Well, thank you so much for coming. And Once again, if you're interested or if you want to look at the replay, maybe you missed the first part of this session, I'm going to go ahead and share my screen properly. All right, let's do that. Okay, I'm just going to go ahead and share my screen real quick. I want to show you something cool. So on our website, if you Google or if you use Bing or whatever search engine you use, but Google TCC space SE space science, and it'll pull up our website, and then you can click on chemistry web resources or workshops and events. Now, under workshops and events, we have all our previous workshops recorded. So check out, that includes our lab workshops too. We actually have a lab workshop that we did today as well for 1406. So if you click on Chemistry 1406, it has the video from last week's workshop along with the materials, but it also has the materials for this week's workshop, including the answer key. So all those other problems that we skipped, there's the full answer key here with all work shown. You can definitely check that out. I'll also be posting the video right here in case you want to take a look at it. In addition, if you go to chemistry web resources, there's also chapter reviews over each chapter, which is very helpful. Practice problems over each topic with answer keys, so you can see matter and measurement, all your conversion stuff, atoms and elements, compounds and their bonds, all practice problems with answer keys completely worked out to help you to understand it better. There's also a comprehensive video tutorial library to the point where this actually could be, I'm not saying you should do this, but it could be a substitute for your textbook if you don't have one, because it literally covers just about everything that you need to know from your book. So, and I take the different videos from different sources. I try to pick out the sources I feel are the very best for each of the topics covered. So these videos have been screened. There's a lot of videos on YouTube. Some of them are okay. Some of them are trash. Some of them are really good. And some of them have mistakes in them. So I watch through these videos to make sure they have no mistakes. And then I look for the ones that are the very best. So this video tutorial library is the compilation of many, many hours of work so that you don't have to try to figure out if a video is good or not. And there's also practice tests and other useful stuff here. But I just wanted to share that with you because I thought it could potentially be helpful. Oh, thank you, Linda. That's very kind of you. Yes, Linda.
How did you say we should go? How did you say we should get to that? I'm sorry, I didn't get it.
Oh,
You're talking very fast.
so just type into like, okay, so actually let me even show you because I think picture's worth 1,000 words, right? So let me go ahead and show you. If you actually just open up like a browser, like I'm using DuckDuckGo right now, but if I just Google TCC space SE space science and hit enter, it'll come up as the top search result. TCC SE Science Learning Center Google site. Or alternatively, if you go to Google, www.google.com, and you just type in here, capital TCC space SE space science, enter, it'll come up with our website as the top site, Google site. And then you can just click there.
Okay, thank you.
It's also in the email I sent you at the beginning of the semester, just as an FYI.
Okay. Thank you so much.
Yeah, you're welcome. You're welcome. Well, thank you so much for coming, and I hope I'll see you guys, see y'all next week. Have a great day.